video on alternate, corresponding and opposite angles. So first of all, let's go through the definition of what a parallel line is. Now, some of you will say that a parallel line never meets, so that doesn't look much of a line. However, mathematically, we're not too bothered as long as we put these symbols in. Two little arrows on there. So hopefully you can see that those are now two parallel lines. Although they didn't look like lines to start with, they're now parallel lines. Let me try and draw it a little bit better here. So two straight lines, and now they're parallel. Two straight lines, and now they're parallel. They can be facing any way, so two straight lines, and now they're parallel. But today we're not just interested in the two parallel lines, but actually we're interested also in the angles that it makes when you cross. So these angles here, what's special about all these angles all the way around here? Well, for this we need to know the name alternate, corresponding and opposite. So let me demonstrate. Here I've got 4 diagrams already done, and we're going to go through those 4 in a second. Let me just put a little bit of space here. So let's go through in red. Let's take this angle, for instance, here. If I know this angle here, it might be 30 degrees, it might be 80 degrees, it might be 60 degrees. It doesn't really matter. But if I know that angle, I know that this angle must be exactly the same size because it's opposite, and opposite angles are equal. But doesn't that mean that this angle here looks to be the same as this angle here? Is that true? Well, yes, because they're opposite too. And this angle here is also opposite to this angle here. Oh, okay. So, by the same token, this angle here is opposite to this one. So, all those angles are equal to each other. So, all we need to remember here is that opposite angles are equal. Now, let's move on to the second one. We've done opposite angles. We know that opposite angles are equal. So what about when we do the next one? Let's do corresponding angles. So again, let me take this blue angle here. This blue angle is actually the same size as this blue angle here, because they are corresponding. That means that they're in the same position. So the way I like to think of it is, if you were to draw a line that went straight through here and cut them, if you were to cut them, make a cut right the way through there, that would be in exactly the same position as that one. So those are what we call corresponding angles, which is quite good. But does that not mean that there are other corresponding angles? Well, yes, you're right. This red angle here is actually corresponding to this red angle here. This green angle down here is corresponding to this green angle down here. And lastly, that black angle there is exactly the same size as this black angle there, because all corresponding angles are equal. Well, we only have one type of angle left now. We've done corresponding, we've done opposite, and now we need to do alternate. So let's have a look. Here we go. If we take, for instance, this angle here, this angle here is alternate to that one. It's on the opposite side, so that's alternate there. And in fact, if we take this red angle here, this red angle is alternate to that red angle. And you may have guessed, alternate angles are equal to. The only exception to alternate angles being equal and opposite angles being equal and corresponding angles being equal is some people might try and say to you, well, can we have anything special about these two angles? Well, yes, there is something special about these two angles. These two angles are what they call co-interior angles. And no, these are not equal to not equal to each other, but are actually equal. They add up to 180 degrees. Some people call them supplementary angles because they supplement each other to make 180 degrees, just like this one does on this side. So you may hear them being called supplementary angles. Well, let's try and put this into context now, so let's do a quick question from down here. I'll just get rid of this up here, and here we go. So, we've been given this question here, so let's try and work it out. Here we go. Let's take it carefully. If this angle is 42 and this angle is 58, then I should be able to work out this angle, not through anything that we've learned today, but because we've got a triangle, and the angles in a triangle, as we know, add up to 180. Well, if I add those two up, we get 100. So this angle here has to be 180 minus 100, which is 80. So C equals 80 degrees. Well, what about A? Can we work out A? Well, yes we can, because A and C lie on the opposite side of this line. And if we go up to here, these two lie on the opposite side of that line, so they're alternate angles. And as we know, alternate angles are equal, so that means that A equals 58 degrees. Now let's have a look. Could we say that these two are on the opposite of that one? Well, yes, we can. So B is again alternate and is 42 degrees. But how am I going to work out D? D isn't alternate to that because this line here isn't parallel. But one thing that I do know, and one thing I can see, is a straight line right the way across here. And angles on a straight line have to add up to 180. So to work out D, we have to do 180 minus 58, which, if we work it out, is 122 degrees. So D equals 122 degrees. Now hopefully you can pause and rewind this video at any time, but that's everything we need to know on opposite and corresponding and alternate angles. Now what I'm going to do, as you can see here, there are 7 exam questions to do. I'm going to take my time working through each of the questions. I'm going to show you the question and then I will ask you to pause the video before I attempt to answer the question. So here we go. Here's question 1. Remember to pause the question. Right, let me start. So we need to work out the size of angle X. We know that this angle here is 47. So we can work out that this angle here is 47. Because opposite angles are equal. So that's the first thing. The second thing is, you could then say that X equals 180 minus 47. X equals but Y. You have to give reasons for your answer. So why? You could say because co-interior angles add up to 180 degrees, and that would be enough. However, I'm going to try another method here. I'm going to do it in red so that you can see it. If that's 47, then this angle here is on a straight line. Can you see this straight line down here? If that's a straight line, angles on a straight line add up to 180. So therefore 180 minus 47 is equal to 133. We did that earlier. So this is 133 degrees. If that's 133 degrees, we can jump straight to this angle. X equals 133. Why? Because alternate angles are equal. So there we go. First question solved. X equals 133. There we go. Now let's try question 2. Let's put it on full page so you can see it. Ooh. So we need to find out the size of the angle marked Y. Well, Y is there and this angle is here, so Y has to be 64 degrees. Why? Well, Y is so Y is an alternate angle to the 64 degrees, so as you know, alternate angles are equal, so Y has to be 64. Now let's try question 3. So here we go. Let's make it full page. We need to work out the value of X, and we're given this angle here is 113. Now, if that's 113, well, I know that this is 113. Why is this 113? Well, it's an alternate angle. And we know alternate angles are equal. Well, if that's 113, X is on the straight line here. So X has got to be equal to 180 minus 113, because angles on a straight line add up to 180, and that makes this 67 degrees. So x equals 67 degrees. Now, you should be able to see down here it says give reasons for your answer. Well, my reasons here are alternate angles are equal, and for this bit here, what did I say? Angles on a straight line add up to 180 degrees. So there are my two reasons. Let's move now to question 4. Remember, you get to pause the video and rewind at any time. So here we go. I need to find this angle here, angle X. Well, this time you'll notice the arrow, the parallel lines are not running straight across, they're actually running on the diagonal. So this angle here is the same as this angle here. So X is 150 degrees. Why? Because they are corresponding, and we know that corresponding angles are equal. This here is slightly different, because that matches this angle. Well, if we know that this is 85, we can work this out because we've got a straight line. So angles on a straight line add up to 180, so if we take that away we get 95. So Y is 95 degrees, and there's two reasons for this. You can say alternate, hence this bit here, and also angles on a straight line add up to 180 degrees. Now let's go for this question 5. You can see the questions are getting slightly more and more difficult as we go along. So here we need to work out this angle. And some of you may think this is quite difficult, but taking it through, what shape have we got here? We've got a lovely big triangle. I'm just going to get rid of my poor illustration, but you can see there's a big triangle around here. Nice big triangle there. So this angle here must be 180 minus, if we add those two together you get 158. So this angle here must be 22 degrees, because angles in a triangle add up to 180 degrees. Okay. Now let me change the colour of my thing here. If this angle here is 22, then this angle here has to be 22 again, because we've got that alternate angle. Now I'm going to change my pen to green. We also know that this angle here has to be 139. Why? Because we have a straight line. Angles on a straight line add up to 180, and we know that there's 41 on there, so when we take that away we get 139. Now for the last bit, for this bit here, we should be able to see that there is a big triangle. And we know that angles in a triangle add up to 180 degrees. So we've got 139 adds up to 22 is 161, but we need to add up to 180. So what's missing? 19 degrees. So x equals 19 degrees. Bit of a trickier one, that one. Let's carry on. Question 6. See if you think they're getting any harder or any easier. Right, for this one we need to work out the size of angle x. Well, I know that this here has to be 38 degrees, but I've got to give reasons. So this and this are alternate angles. Here's something a little bit more tricky though. You can hopefully see this triangle here. Well, actually it's a special triangle. It's an isosceles triangle. So although it adds up to 180 degrees, we know that this angle and this angle are the same size. So 180, take away 38, is 142, but because these two are the same size, we then do 142 divided by 2, and we get 71. So this is 71 degrees, and this is 71 degrees. Unfortunately though, we haven't finished there, because I need to work out this. Now this bit is on a straight line, and we know that angles on a straight line add up to 180 degrees. At the moment we've got 71 degrees, so taking them away and we'll find that we need 109 degrees. So x equals 109 degrees. Now we come on to the final question. Remember, you can pause and rewind at any time. And let's go through this one. So here we go. It looks tricky, but let's take it one step at a time. We need to work out x, which is here. So far, I know that this angle is 53, so let's put in the angles that we know. I know that this angle has to be 53 because it's alternate. I also know that this is 53. Why? Because it's opposite. Well, if I know that that's 53, I can work this one out here. This one here is on a straight line. So this one is 180 minus 53, which is 127. So I'm just going to shade that in and draw a big arrow going from it. 127 degrees. I know that this angle here is 28 because it's opposite. So I've now got all the angles in this triangle apart from the x that I'm looking for. We've got 127 and I've got 28. When I add them together, we get 155. So I can work out x because angles in a triangle, and you can see this triangle here, has to add up to 180. 180 take away 155 is 25. So x equals 25 degrees. Now, that's the end of the video. You've seen all the questions, but remember, you can pause and rewind at any time.